Hello, welcome to this episode of How To Videos. We will go over one important connector found on EK boards, the PMOD connector. Now, the PMOD connectors are a 12-pin 2-row connector system designed for peripheral modules or PMOD. It allows for quick plug-in of modules and various connectivity types such as UART, SPI, I2C. On a Renesas EK board, you may find one or two PMOD connectors that accepts sensor boards, IoT peripherals, or simple signal processing units. On the EK RA6M4, you will find them on the expansion area on two opposite edges. By default, the PMOD connectors support SPI or UART communication being categorized as Type 2A. The PMOD 1 may be configured into Type 6A, allowing I2C communications by modifying some connections on the board. In general, both PMOD can operate parallelly with two independent SPI or UART channels. There is also an option to convert the VCC pin to plus 5 volt if any peripheral needs it. There are 6 traces as mentioned here that need to be modified to configure the PMOD 1 port for specific communication modes. The PMOD 1 port is the configurable one as tabulated here. From the user's manual of the EK RA6M4, we can see that 2 signal pins need reconfiguration through the modification of 4 traces marked E29, E33, E36 and E37. The other GPIO pins, interrupt pins, are tabulated here. Moving on to the PMOD 2 ports, it's not configurable and is hardwired to support SPI or UART connections. The exact pin numbers can be found on this table. Looking from the front of the ports, the standard PMOD layout starts from the right with pin 1 and continues to the bottom row from pin 7 on the right again. The leftmost pins on top and bottom are both supply voltages VCC, and the pins next to them are connected to the ground. Now, we are going to run through a small demo project. Since PMOD ports are just communication ports, we will set up a master-slave SPI data exchange application. PMOD 1 will act as a master channel, sending data to PMOD 2, which is connected to a slave channel. The slave channel will then revert back a data based on the received data. The connections are pretty simple. Since it is SPI, all the corresponding pins need to be connected. That is, the master out slave in connects to the corresponding master out slave in on the other port. We got 2 signal pins and 1 clock pin. Let's open a new E2 Studio workspace where we are going to import a SPI 3-wire communication application. We are going to look for the compressed folder for the project. Select that and import. Once the project has loaded, we shall open the configuration.xml file by double-clicking it and then navigate to the Stacks tab. We can see the PMOD settings here, which are configured through the SPI stack. We click on the first stack, which is named Master. Since it's a complete project, we just need to check whether the configured pins for the stack match the PMOD connections. Well, we can see that pins 202, 203 and 204 are assigned, which are the very ones connected to the PMOD 1 connector. Moving on to the slave SPI stack, we can see that pins 410, 411 and 412 are configured, which correspond to the pin configuration of the PMOD 2 port. As the pins look okay, we can simply build the project and then debug. Once the project has been compiled, we need to extract the block address for the Sager module from the .map file found in the debug folder. This address will be used in the JLink Sager RTT viewer terminal to display the text. In the RTT terminal, we can see that there is some data being transferred from the master to the slave, and then the MCU adds 2 with that input and sends back the result. This is just a simple demonstration of the communication that happens between the 2 PMOD ports. So that was our little walkthrough with the PMOD ports. You can now configure these ports to interact with the many peripheral devices that come with a PMOD connector. See you soon in the next video.